All right, for the last part of the 2.2 part 1 that we're going to do today, we're going to talk about standard form here. Okay, standard form, of a quadratic is when it is written as ax squared plus bx plus c, and a cannot be 0. Because if a was 0, you wouldn't have x squared, and then it would be linear. So for it to be a quadratic equation, it has to have a. It does not have to have b and c, but a has to be there. Okay, and then let's come down. We'll talk about some of those others later. But when we are graphing it in standard form, so far we have been graphing in vertex form. And vertex form was a times x minus h squared plus k. All right, and that was when it was f of x. That's vertex form or graphing form. Gives you the vertex right off the bat. The problem with standard form, it doesn't give you the vertex. You don't know where to start. But there is a little equation that helps you find that. Remember, the x value of the vertex is the x value of the axis of symmetry. So, and the axis of symmetry is x equals a negative b over 2a. So as long as you have b and you have a, now it's okay. If b is 0, then it's 0. That means your axis of symmetry is 0. But as long with b and a, you can find that axis of symmetry. C does not matter. C is actually only giving you the y-intercept. Okay, because if x is 0, that means this would be 0 and this would be 0, and it would just be y equals c. That is where, when x is 0, that c is where it crosses the x-axis. I'm sorry, the y-axis. Wow, I cannot talk. Okay, now once you find the x value of the vertex, which is also the x of the axis of symmetry, you can find the y value by plugging that x in to the function, and what you get when you plug that into the right side, that's what y equals. And so let's do an example like that. So let's do number 2. All right, so I'm going to draw a line. I only want vertex, axis of symmetry, and I want to graph this. So I first need my x value. I need that axis of symmetry is where I'm going to start on this one. On this one, we started with the vertex. Here, I'm starting with the axis of symmetry. And it is negative b over 2a. All right. Remember, this is a times x squared plus b times x plus c. So a is the coefficient in front of x squared, so a is 1. B is the coefficient in front of x, which is 2. C is our constant, which is 1. Okay? So I'm going to plug that in. I have x equals negative, and in this case my b is 2, and it's over 2 times a, which is 1. So that is a negative 2 over 2, which is a negative 1. So my axis of symmetry is x equals, oh, what just happened? Sorry about that. Let me scroll that up. X equals negative 1. Okay, so I have my axis. So in my vertex, I know the x value is negative 1. So to find the y value, everywhere I have an x here, I'm going to plug in negative 1. So if I rewrite that, because it's kind of messy up there, I'm going to have f of x equals, which is the same thing as saying y equals, negative 1 squared plus 2 times negative 1 plus 1. Again, I just plugged in negative 1 into those x's, because that's what I said, x equals. If I can just from there plug it all in my calculator, making sure the negative stays in parentheses when I'm squaring it. If you don't square the negative along with the 1, then you're going to get a negative number, which is wrong. So make sure that you're squaring it correctly. So if you're punching it all in the calculator. So if I don't punch it all in the calculator, I know negative 1 squared is positive 1. 2 times negative 1 is negative 2 plus 1. So I have a 1 minus 2 is negative 1 plus 1 is 0. So I know the y value of my vertex is 0. So I can go ahead and plot the vertex, negative 1, 0, right here. Okay, if I were to plot that y-axis, axis of symmetry, it's right there. I know that yellow is horrible. Sorry about that. And then we have those points to plot: 0, 0, 1, 1, 2, 4, 3, 9. Remember, the y value is always the x value squared because that is our parent function when we deal with quadratics. There is nothing multiplying x squared. Okay, our a is 1. So I am not multiplying the y values by anything. So from the vertex right here, I'm going to plot these points. Because remember, this 0, 0 became our vertex. So from there, I go right 1, up 1. And I put a point, and I go left 1, up 1. You got to do it on both sides of that axis of symmetry. I go right 2 from the vertex and up 4. And left 2, up 4. Notice these are the same distance from that axis of symmetry. Okay, from that vertex, I go right 3, up 9. That's a little off my graph. I'll still put it. I also go left 3, up 9. Now I can connect my dots. It is a curve. There is not a point at that vertex. I mean, it's not pointed. It's not sharp at that vertex. All right, so now I graphed it, found my vertex and axis of symmetry. So let's come down and do number 3 here. Oh, and it kind of goes sideways, so instead of up and down. So we first need to find our vertex, and let's label. We know a is what's in front of x squared. It's the coefficient of x squared, which is 3/2. B, it's -1 because it says negative or minus x was the same thing as saying -1 is in front of x. And then our C is -1. For the vertex, we only really care, or the axis of symmetry, we only really care about A and B because remember it is -b over 2a. So at some point you need to memorize that. -b over 2a, -b over 2a. Say it over and over, make a little song for it, something. Get that in your head. So if I plug in my values, I have negative, and b is a -1 over 2 times a. All right, so on top I get 1, on the bottom I get 3, and that is as simplified as that gets. So I know my axis of symmetry, and we're going to stop there today, is going to be x equals 1/3. The axis of symmetry is a line. It has to have an equal sign. You have to have the x. Don't just write it. Axis of symmetry is 1/3. That means nothing. 1/3 in a coordinate plane is nothing. I can't even put that on the coordinate plane. You have to have the x equals. All right. So with my vertex, I know the x value is 1/3. I need to find the y value. So I'm going to take that 1/3 and I'm going to plug it in here. For x, I'm going to plug it in here for x. Again, you can use your calculator, or you can calculate it by hand, by squaring the correct things and all of that. And you do get, whoops, sorry, if I go right back to the right color, that y equals a -7/6. Notice I'm leaving those as fractions. If I were to put those as decimals, they go on forever. And I don't like rounding when I'm actually giving an answer, unless it says round to the nearest hundredth. 1/3 and 7/6 are exact. I'm going to leave it that way. Now, when I graphing decimals is a different story. Graphing fractions versus decimals is a different story. So let's graph that vertex, okay? So 1/3, just visually seeing 1/3, it's 1/3 of the space between 0 and 1, but graphing 0.3 is a little easier. So I go to 1/3 and down -7/6. That's 1 1/6, or so it's like, okay, so 1/3 over and down, because it's negative, we'll put that point right there. All right, I know it's not exact, but that's because we're drawing it, and things aren't exact when you draw it. All right, we need those starting points. 0, 0, 1, 1, 2, 4, 3, 9. Now, there is an a that is no longer 1. Whenever a is no longer 1 or it is negative, we are going to multiply the y values by that number. So multiply by 3/2 or 1.5. So when I multiply all the y values, I get 1.5. 4 times 3/2 is 6. 9 times 3/2 is 13.5. All right, so this blue dot right there that I put on there, that is my vertex. That's what we plotted right here. So that is the 0, 0. So from there, I'm going to go right 1 up half, which is about, I'm sorry, up 1.5. Did I say that? Right 1 up 1.5. I also have to go left 1 up 1.5. Oh, and don't forget our axis of symmetry. Oh, that yellow is just horrible. I needed to change it. I keep forgetting. Our axis of symmetry is there. And see, those points are the same distance from that line. The next point is right 2 from our vertex up 6. 1, 2, 3, 4, 5, 6. And left 2 up 6. We're not going to be able to fit the 3, right 3 up 13.5. So I know I can graph going to my vertex and back up. Okay. So this one has a minimum. If when we get to that, we kind of talked about minimum on the last one, but it has a bottom to it. But we'll get to max, min, domain, range, increasing and decreasing on the next day of school that we have this class. So now that you've done that, now that you know how to find the axis of symmetry and vertex for equations that are in standard form, ax squared plus bx plus c, you can now do problems number 21, 22, 26, 33, and 34 on 2.2 practice number 1. That will finish off that practice, and you can submit it in Big Ideas. Take a screenshot of your results page and submit that on Canvas.